video is going to have a look at a technique called a titration, and the purpose of titration is to find the concentration of a solution of an unknown concentration. In order to do that, you need to have another solution of which you do know the concentration. Now, we're not going to go through the whole sort of analysis of the data side of things, and we'll do that in a different video, mostly because that comes up in the separate sciences and in the A level. So for the combined, we're going to have a look at the techniques, the apparatus, and the data that you will collect. So let's have a quick look at those. So when I set this up, this is a basic setup, and this is sort of a diagram, and this is what it actually looks like. Now, we'll start off down here. Now, you've got a conical flask here, and what we normally put in is we normally put the alkali in. The only reason we normally put the alkali in is because we normally use sodium hydroxide, and sodium hydroxide tends to block up the tap. And there's no other reason for it. So I'm going to put a solution of sodium hydroxide with a known concentration in here with some phenolphthalein. The phenolphthalein is a indicator that turns colourless in acid, but it's bright pink in a base. And I therefore need to add that in with a known volume of my known solution. And the way I'm going to add a known volume is to use something called a volumetric pipette, and they look a little bit like this. And they've got this bulb, and what you do is you suck the alkali up from the stock solution, and when it gets to this level here, so where that line is, that will give you an exact volume, including the bit that's left in the tip at the end when you pour it out. And these come in different sizes. So you've got some that are 10 centimeters cubed, 25 centimeters cubed, 50 centimeters cubed, whatever. So if we take our alkali, we fill it up with a known volume, with a known concentration. That means we know how many moles of sodium hydroxide are in that solution. And I put that into my conical flask. I then fill up my burette with acid up to the top mark, ideally. You could go a bit below, but you can't go above. So you cannot go above because you have no readings. Now, I'm going to fill that up with acid. And as I pour it in, so I open up the tap, and this is what it looks like. And I'm going to swirl this around. I'm going to put it onto a white tile. The reason I'm going to do that is so it's easier to see the colour change. And I'm looking for it to go pink, from pink to colourless, and that's a very, very quick change. Okay, pink to colourless. Do not say clear, it's colourless. Now, when it does that colour change, I'm going to immediately turn off the tap, and I'm going to take a reading. And on that reading, it's going to look like this. So as you go down the burette, you'll see these markings, and you'll see that the solution forms a little dip. Now, that dip is called a meniscus, and your instant reaction would be to read it from here because this is the highest point. However, it's all accounted for that you don't do that. So you would read it from the bottom of the meniscus, so just there, a little bit lower than that, just there. Okay, and the reason you'd do that is just because that's how we measure it. The other thing to bear in mind is if I'm looking at it from up here, as I look down, I am going to be reading from up here, not down here. So even if I look at the meniscus, it's going to end up looking like it's up here somewhere. I therefore need to make sure that when I read this, I do it from eye level so that I get the bottom of the meniscus exactly. All right, and once I've done that, I have got what's called a rough titration. The next time I do that, I take this volume of solution that was used. I can fill this up to the top again, or I can leave it there as long as I've got enough still in the burette. I open the tap up. I need to empty this out and replace it with the same volume of the same solution again. But I then open the tap up, let the acid go in, and about 10 centimeters before the volume I last used comes up, I turn the tap so it's almost closed, so close to being closed that only a little drop comes through every now and again. All right, keep swirling this, and then once it goes colourless, the second it goes colourless, turn off the tap. All right, you're looking for a pale pink colour, and once you turn off the tap, then you get what's called an accurate titration. So you've got a rough titration and an accurate titration, and you'll get results that look like this. So you'll have a rough titration. It's always going to be a slightly bigger volume, the titer. You are also going to then get some accurate titrations, and they should be very close. And what you're looking for is two concordant results, and these would be concordant results because they are identical. Now, sometimes they will give it to you like this, sometimes they will give you three of them, but the volume that you use as the volume of unknown solution will be an average of your concordant results. Now, if I got this, I would use 23.80 just because they are exactly the same and it's easier to calculate a mean. They will give you easy numbers in the exam if you have to do this. However, or they normally give you easy numbers, I should say. They don't always, but usually they do. However, you would be just at right if you added all three of those together and divided by 3 to get an average titration. And that will be the volume of the unknown solution. Once you've done that, you can then start figuring out the moles and you can figure out the concentration of the unknown solution.